So it's another identity to verify. Okay, so it looks like the left-hand side is more complicated, so we'll work with that. Interesting to note, I only have one term in the denominator, cosine alpha, cosine beta. So that's multiplication down there. That could be very helpful. Up here in the numerator, we're going to use that difference formula for sine. Seems to be a popular one today. Okay, so sine alpha cosine beta minus cosine alpha sine beta. And then it's going to be over cosine alpha cosine beta. Now you might be saying, well, why don't you do something with the denominator? Well, there's not really anything to do with it. I mean, I don't know what we could do with it. Okay. So, but what we can do now is we can split it up. Because this is only one term down here, I can split up the subtraction into two separate pieces. So I can have sine alpha cosine beta over cosine alpha, cosine alpha cosine beta. You do have to be kind of careful. I'm not writing very neatly, but you do have to be careful because you don't want, your alpha to look like a beta or something. Cosine alpha sine beta over cosine alpha cosine beta. Okay, now why is this a good idea? Well, notice on the right you have subtraction, right? So if I can get one piece minus one piece, and then if I can get those two pieces to, be the right thing, then that'll be great. Okay, cosine betas are canceling there. Cosine alphas are canceling there. And so now, scroll up a little bit, I've got sine over cosine, sine alpha, cosine alpha. Those have to match, by the way. And that's going to give me tangent alpha minus, and then I have sine beta over cosine beta, which is tangent beta. And that should be what they wanted. So you could have taken one more step in here to write, sine alpha over cosine alpha and sine beta over cosine beta. But I didn't. Sorry. Okay.